So I'm Peter de Dekker. I'm a professor at the University of Leuven, at the KU Leuven in Belgium, and I'm also proud to be one of the international chairs at the University of Lille. My research focuses on trying to visualize the small details of life by building microscope and molecular probes that can be used to visualize biochemical processes as they happen in cells. In essence, what we like to do is to understand at the molecular scale how living systems grow, evolve, prosper, but also can become sick, and how these mechanisms can help us understand how to improve these processes and help to, for instance, develop therapies that can help us live healthier and happier lives. So the Deep Sea project is designed to tackle an acute new opportunity and challenge that we face now, and that is the fact that we are increasingly beginning to realize the full complexity of biological systems, which is again not only important for how they evolve, but also is seen in, for instance, cancer, where we see that tumors are extremely heterogeneous or complex, and that this complexity affects how these can be treated and how this treatment can be best conducted. And now we have been developing, together with other groups, new ways of visualizing such systems to better understand their functioning. Within the Deep Sea project, our goal is to build an entirely new type of microscope that will be especially suited to see fast processes or complex processes in systems consisting of many different cells. Now, to do this, we will need to combine multiple expertises, and this will be excellently suited to the expertise between Leuven and Lille. In particular, from Leuven we are very strong in the optical design of the system, but in Lille there is an extremely strong component at the LASIR that we will be working with in this project on the development of advanced data analysis strategies, and also even translating this into smart control of the imaging. And so we will build an entirely new type of microscope, an imaging modality that can visualize samples like tumors in a way that has never been done before. Especially attractive also within this international chair position is the presence of knowledge within oncology and cancer treatment, and so we will, together with the Canter team at the University of Lille, we will apply our tools, our methods, our software, our developments to studying pediatric tumor models in the hopes of developing better treatment options and better approaches to cure these diseases that are associated with far too poor prognoses until now. So the collaboration between Leuven and Lille is essential to realizing this project. First of all, I would like to say that I've already had for many years a very nice and productive collaboration with researchers at the Université de Lille, and of course I am very excited in being able to continue this. And within the International Chair project of Deep Sea, we are now finally getting the tools to do this properly, and I am particularly excited about combining the expertise on optics and molecular probes that we have in Leuven with the expertise on sophisticated data analysis and online decision making to optimize the acquisitions that we need to do. That is present here in Lille, particularly within the LASIR team. And finally, I am also extremely happy and optimistic about the prospect to be able to combine these steps forward with the knowledge that is present within the Canter team at the Université de Lille, who are really leaders in the development of tailored and personalized treatments for conditions such as tumors and other forms of cancer and diseases.